I'd like to welcome you to this session this afternoon. My name's Dr. Robert Ian Whitfield. I'm from the University of Strathclyde in Glasgow, Scotland. The session that we have this afternoon is New Trends in Design Education. We have 5 presenters. I think 4 of them are definitely here with us. Those presentations that we got. The first one is Testing in Engineering Design. What are we teaching? And Khadija will be presenting that. The second presentation we have is Improved Approach to Implement Design Education for Additive Manufacturing using an RC model race car. And Stefan Junk will be presenting that. After that one, we've got Emerging Material Research Trends, Fostering Critical Material Research in Design Students. Flavia will present that. The fourth presentation is a gap in design creativity education between China and developed countries. Zhengya will present that one. And last in this session this afternoon, we have a writing typology for designers, and Madison will present that. I'd like to see questions coming up into the chat, so please do put those questions in there. It's probably helpful if we can direct them at whoever is presenting, so please make sure that it's clear in relation to who the question is actually aimed at. As I said, what we'll try and do is give Flavia a bit of chance to look at the questions that are directed to her, and it looks like she might have to respond through the chat herself, so we'll follow it that way. But I'll moderate those questions when we get to them, and I'll try and make sure that everyone has questions directed towards them. So in the meantime, Ivan, if you can start the videos. I understand that it'll be around about 30 minutes, and then we'll go to questions. Over to you.
Hey everyone, my name is Apurva, and today I'm going to be talking about testing in engineering design and what are we teaching on that subject. This is collaborative work done with Khadija Tahera at the Open University Business School, working with myself, Dr. Joshua Slummers, and Dr. Murphy at the Mechanical Engineering Department in the University of Texas at Dallas. Just a disclaimer here, this will not be a summary of the paper in service of time. I'll just talk about a few key things and use this as a teaser for the paper. So with that, let's get started. A quick background of testing in design and education. So testing is needed for verification and validation of products. We may use different forms of testing for that. It may be material testing, where we're trying to see if this is the correct material. We may be testing the functionality of the product, or we may even be doing user experience testing. We also use testing for exploring new ideas or experimenting with our existing products, testing its limitations, or we may be using testing to learn how our product behaves in different environments under different loading conditions, those kinds of things. In terms of education, testing is mostly discussed in the capstone design programs, and even there it's inconsistent as for what is exactly covered, whether it's mentioned explicitly or implicitly is not consistent across programs. What types of testing should be used and what kinds of documentations are needed to go along with the testing are not consistent across programs. A recent survey done in 2019 with 445 respondents found that 73% of programs surveyed did not explicitly address testing in the course at all. So with that, we wanted to take a look at what is actually being taught in testing, and we're taking a narrow but exploratory approach here, where we're looking at design textbooks that actually are used in mechanical engineering programs. So we found 11 design textbooks that were highly cited and commonly used in programs within the United States, and we developed a short protocol to review these textbooks. It's essentially a 3-step process. First, we check if testing is discussed in the book. We may be doing this using an electronic search or index lookup, depending on the medium. Then we want to look at the context for testing. So where is it found? Where within the book? What chapter number? What page numbers? Where along the product development process? So is it found early in the problem definition stages, or is it discussed very late in the production and manufacturing stages, or somewhere in between? And finally, we wanted to identify, in this phase, we wanted to identify some adjacent terms or testing related terms that appear in the book. And the third and final step here is we wanted to capture if there are any documented processes that are identified for in the book, or if they outline any clear definitions for testing. And we also recorded any interesting or illustrative quotes from the book that show what the authors are thinking when they talk about testing. So jumping to some of the results here, where is testing discussed? Mostly we found testing prevalent in the conceptual design space or conceptual design phase. I think we had 7 out of 11 books discussed testing in that phase. It was also found frequently discussed in the embodiment design and detail design phases. It was less common in the preliminary stages, so pre-design or problem definition stages, where testing is discussed in maybe 1 or 2 of the books we surveyed. As far as adjacent terms, we found a few terms that were discussed alongside testing, and some of these are going to be familiar, such as verification, validation, prototyping. So experimentation was the most commonly found term alongside testing, which that makes sense. Some of the other terms that were commonly found were prototyping, modeling, verification, validation. Some of the terms that were present in 1 or 2 of the books, but not in abundance, were discovery and simulation. So maybe those are more specific or particular to a specific type of testing. So to conclude this presentation, I would like to talk about a definition for testing and some recommendations. So we started this work wanting to know how testing is defined and taught within the classroom. We didn't find many definitions for testing in the textbooks. So based on the information we found, we came up with a working definition here. Testing is the process of evaluating a proposed design with respect to the design requirements. And this is a working definition, so your comments and criticism are welcome. As for recommendations, we think there should be an increased focus on formal approaches to testing, so a structured way to carry out the tests and then sequence the tests to learn what we want to learn about the product. We should emphasize the role of testing in each design stage. Just reiterate that testing is important at several levels of the product development. And we also want to familiarize students with various types of testing so they know how to select the correct type of test in order to learn the information they intend to learn. And finally, some limitations of this work. So we approached this from a narrow perspective, looking just at textbooks. And even there, we did not do an exhaustive search for textbooks. Within the textbooks, we only evaluated what was in the books, right? So students learn more things about testing potentially from the faculty member teaching the course, from participating in the design project. So there are other things that are not included in this work. And with that, I would like to thank you for your attention, and we welcome any questions you may have.
Hello, ladies and gentlemen. I welcome you to my presentation about an improved approach to implementing design education for additive manufacturing using a radio-controlled model race car. The motivation for this work is that in the last decades, the variety of methods in additive manufacturing, as well as their fields of application, have grown enormously. In order to exploit the possible potential of this new technology, the special features of the layer-by-layer structure and resulting material properties must already be considered during the product development. However, education and training are often still focused on conventional manufacturing technologies, so that many engineers today have only limited skills and knowledge about AM. To address this shortcoming, a number of textbooks and design guidelines have been edited. In addition, several universities have established lectures and seminars that consider design for AM. However, these courses typically utilize labs that provide access to a limited number of 3D printers. This allows students to use the labs, but unfortunately, they often lack a deeper understanding in terms of manufacturing technology and its capabilities and limitations in practical applications. This literature review raises the questions of how students can independently develop solutions in a course using methodical approaches in order to develop and implement a product to be manufactured using AM. In this contribution, the specific course Workshop Rapid Prototyping will be used to investigate how master students in engineering acquire the competence to understand these new manufacturing technologies. In particular, it is to be determined which competences and what extent they are improved by this course. Also, the question is to be clarified which parts of the product development process have a particular strong influence on the acquisition of competences. In this new course, a remote-controlled racing car is used as a practical example. The CAD data of the individual parts can be downloaded by the students from the freely accessible internet platform called Thingiverse. The students are given access to two different printing technologies. The student's task is to analyze and to optimize certain assemblies. It must always be considered that additive manufacturing will be used in the production of the optimized assemblies. In addition, the students must develop criteria to evaluate the technical value of the optimization. This task is carried out in 2 or 3 teams of 3 to 4 students each. These teams have 1 semester to complete the optimization, which represents about 90 hours. In order to learn a methodological approach, they use the development method called with the German acronym SPALTEN. This methodology describes a universal approach for handling problems with different boundary conditions and degrees of complexity. It is introduced by Professor Albert from the Karlsruhe Institute of Technology. During the process, regular meetings with the lecturers take place in order to check the current status of the work and to clarify current questions. A practice session, including a test race, is held 1 week before the final presentation, so that the teams can evaluate the performance of their solutions, and they can also assess the gap between themselves and the competing teams. At the end of the semester, the final presentation is held in order to present the results. The situation analyses show that when driving over uneven road surfaces, the vehicle is hardly controllable. In addition, there's a frequent occurrence of fractures in steering knuckles and steering components at the front, and wheels are falling off. The geometry of the steering system has to be adapted to increase the installation space for the springs. Several optimizations were required for the guide on the front spoiler to find a clearance-free and smooth fit. Among the sessions learned is that the direction of printing is crucial for accuracy and the stability of the components. In addition, the washout support material offers many advantages. Also, fits have proven printable, but they are difficult to adjust. In order to determine the learning success of the students, the self-assessment in the course was determined with the aid of a questionnaire. The first step was to find out how the knowledge of the students differed in several areas before and after the workshop. For this purpose, the students could indicate their knowledge with the help of points from a range from very little knowledge to very good knowledge. Particular improvements can be seen in the areas of estimating the necessary printing times and practical knowledge about additive manufacturing. Also, the competences in design, which means methodical and sustainable design, have been significantly improved. In the additional survey, the students were asked what contribution various parts of the course had made to the optimization of the product. It showed that the test drive and races made an important contribution to the optimization. Also, students were asked which phase of the product development process accounted for the largest share of optimization. Here it shows that almost all phases of the product development contribute an equal share to the optimization of the product. The presented course, Workshop Prototyping, has shown that the students are enabled to develop innovative technical solutions for demanding tasks. In this workshop, the students acquired both important knowledge of methodical design and the ability to implement it with the help of additive manufacturing technologies. In particular, the students developed a new suspension and adapted it to the existing chassis. They also developed a very practical solution for the quick change of the front spoiler. In both developments, all steps of the trial method were successfully applied. The evaluation of the course shows a very positive feedback from the students. Thank you very much for your attention, and please feel free to ask questions.
Good morning, everyone. I am Flavia Papile, PhD student in design at Politecnico di Milano, and today I'm going to present this research work conducted in collaboration with my colleagues Lia Sossini, Andrea Marinelli, and Professor Barbara del Curto. The main aim of the presented work is to envision a new modus operandi pattern that could enable the monitoring of material research trends and foster a critical analysis of them in design students. New materials often represent the starting point for product design innovation. By practicing and interacting with prime matter, designers are able to envision new product possibilities and trigger the design creative process. Since the number of innovative materials trying to address the sustainable objectives is increasing rapidly, we are assisting to a phenomenon of misleading definition of innovative material classes. These new materials often show peculiar characteristics and properties, and most of the time they behave or change in direct correlation with their environment, and sometimes they are rediscovered in their purity or with new established aesthetics. Therefore, new materials hardly match with traditional material classification, demanding for designers not as creative manipulators of matter, but with totally new roles in material interpretation and deploy. New materials emerging from new material design practices slowly detach from traditional material families and classes. The exercise of finding a new way to define emergent material classes is not a novel attempt in design literature. Previous authors tried with their work to narrate this difficulty to remain into traditional material classes. Therefore, it becomes fundamental for designers to define some guidelines to navigate in this new material panorama. In this work, the authors highlighted the emerging trends in material research and design and defined a repeatable and adaptable modus operandi to be used to monitor case study materials. The objective was to set up the basis for a repeatable methodology for tracking the new material classes offered to designers and possibly embed the new trends and tendencies that may arise in future. To monitor the new materials panorama and provide a useful picture of materials research and production trends, in this work the researchers, together with design students, carried on an extensive case study analysis. In this work, an alternation of back-office tasks conducted by the research group and students' didactic activities led to the identification of material research trends that are useful for the designer's activities. Research through online databases, books, and literature proved to be essential to understand how material research in design is shifting towards the new materials alternatives, not matching with classical material classifications. Research upon most common novelties found on online material databases and books allowed the researchers to identify some clusters that could contain those new materials. Consequently, 6 different material trends were identified and defined by the authors as presented in figure. The authors presented the above-mentioned material trends to the learners enrolled to the Nanotechnologies and Functional Materials for Design elective course at the Design School of Politecnico di Milano. As part of the teaching-learning activities, the learners, in single or small groups up to 3 people, selected one trend of interest and explored it through a deepening activity, following either a vertical or a horizontal approach. Case studies retrieval was an essential part of the didactic activities, allowing the students to be up to date with new technologies, processes, and materials. And most importantly, they could open discussion during classes that may improve students' transversal skills, such as stimulating both critical and comparative analysis on the retrieved solutions. As outcome, they produced a written elaborate in which case studies had to be reported to support their argumentation, And all case studies created a collection available to the students that was subsequently reviewed by the authors and re-elaborated as a restitution, which the students could use for parallel or following courses. An inquiry format guided the analysis and description of the case studies in terms of technological transferability, technological maturity, and possible other deploys of the same material. In order to provide a clear visualization of the results collected with the case studies analysis activity, the researchers at this point were able to review the results provided by the students and cluster them as follows. First of all, the data provided by the students were cataloged in an indexed table through the main categories of the case study schedule provided to the class. Secondly, the matrix fulfillment allowed the researchers to build a database of case studies. And at this point, the complete database was deployed to realize some graphic visualization to effectively describe some dimensions concerning the new material categories defined by the authors. A total of 74 different case studies were collected and systematized. To provide a contemporary overview, the students were recommended to prefer case studies no older than 15 years. Hence, the case study collection is populated by cases from 2006 to 2021. The amount of case studies collected depended on the number of course attendance, if they were working in single or group, and from the students' personal discerning criteria to evaluate as exhaustive for the proposed work a certain number of case studies. Case studies emerging in the functional trend are the oldest, and over the years, they have been of growing interest. Rediscovered materials, on the contrary, grew only in the last few years, depicting an impellent necessity of creating new materials from waste. The same trend has been followed by foodology materials, while bio-XXX and biomimetic materials maintained a constant research interest, according to the analyzed case study basin. Alive materials, instead, represent the most emerging trend. Although a small number of case studies has been collected, it seems that research is raising its interest in alive materials. It is interesting to appreciate how case studies concurring in the same class generally showed an increasing industrialization level over the years, as a confirm of industry adoption of these new material solutions. Possible mixture among different case studies is proposed in this figure. Some case studies, in fact, overlapped in between different material research trends, highlighting how the research on certain topic is in ferment. For most of the case studies, no intersections were identified. Nevertheless, the trends with the most interactions were foodology, followed by alive, bio-XXX, and rediscovered materials. The case study collection activity was carried out by students using familiar tools to them, through not attending, for example, the ones that traditionally are used by engineers. Since the collected case studies were retrieved through different drivers, the consequent outcomes were firmly biased by the research methodology adopted by every single student. In order to overcome those biases, the presented procedure will be repeated in time in order to monitor new material research trends. This activity, in fact, allows both students to develop curiosity and critical thinking when finding new material solutions for their projects, but also to consolidate material research trends over time, contributing in the definition of possible innovative material classes. To effectively evaluate its repeatability, the authors will apply such methodology over the incoming years. As an advantage, the methodology allowed the authors and the students to transcend the assignments to elaborate considerations about the market and evolution of the trends. And with these few reflections, I can conclude and thank you for the attention.
Hello everyone, I'm Zhengya Gong, a doctoral researcher at the University of Laodu. Today, I'd like to talk about the gap in design creativity education between China and developed countries. We conducted the study to answer the following questions. Is there any difference between creativity-related courses in higher education between China and other developed countries? Is there any difference in motivation for participating in the related courses? What are the adopted creativity methods and the effective creativity methods in the related courses? And what is the valuation of those adopted creativity methods? Why we targeted this topic? Because creativity is an essential ability and learning creativity methods is important, which enables individuals to use opportunities and better respond to challenges in their career and personal life. However, a few studies have indicated that Chinese higher education focused on essential knowledge and skills rather than fostering students' creativity. However, there is still absent a survey to investigate the cultivation of creativity in higher education in China and to compare the difference of creativity cultivating between China and developed countries in recent years. How to get the results? By the questionnaire that included 3 sections: background, creativity-related course, and creativity methods investigation. Participants recruited online who from different countries, such as US, France, Sweden, UK, Finland, and so on. For collecting valid responses, we set exclusions. We collected 85 valid responses to investigate the participation rate after excluding developing and undeveloped countries, also irrelevant occupations. 58 participants were from China and 27 were from developed countries. In the second exclusion, we collected 32 valid responses to explore the differences of creativity-related courses by excluding 53 responses who haven't participated in a creativity-related course. 14 participants were from China and 18 were from the developed countries after the second exclusion. For answering the first question, participation rate, 53 participants haven't participated in the creativity-related course, accounting for 62.4% of 85 participants. Only 24.1% of 58 Chinese participants had participated in the related courses, compared to 66.7% of 27 participants from developed countries. We asked what motivated you to join in creativity-related courses in questionnaire. Chinese participants had a more positive attitude for participating in a creativity-related course than that of developed countries, especially in 7 items as shown in the figure, such as gaining interests and free expression, and so on, with a statistic difference. Regarding the third question, popular creativity methods, the results showed that the most popular creativity methods were mind mapping, brainstorming, thinking outside the box, role-play scenarios, and storyboards. Although mind mapping was the most frequently used method to enhance creativity, the followed popular creativity methods differed between China and the developed country. The frequently adopted creativity methods for China were brain writing, brain drawing, thinking outside the box, and brainstorming, while the following frequently adopted creativity methods in developed countries were storyboarding, brainstorming, mood boards, and real-play scenarios. The most effective creativity methods in our study refer to the creativity method perceived as effective methods by participants. There were differences in the effective creativity methods between China and developed countries. From the participants' perspective, the most effective creativity methods in China was brain drawing and mind mapping. Mind mapping was also the second most effective method in developed countries, followed other methods that reported by the participants, such as sketching and art-based methods. For the evaluation of creativity methods, the highest mean was creativity-related courses improved my creative ability. Students from developed countries are more familiar with those methods, and the Chinese participants feel more relaxed and pleasant than developed countries. Overall, on the one hand, although creativity is essential for all individuals, creativity training in higher education is insufficient. Only 24.1% of participants from China joined in a creativity-related course, and all of them were studying arts or design. That means there is still a gap in cultivating creativity between China and developed countries. On the other hand, Chinese higher education offered creativity-related courses. Educators applied creativity methods in those related courses. And the Chinese higher education, including students, educators, and universities, valued creativity. Therefore, we suggest that universities might provide more creativity-related courses for each discipline. Thank you for listening. If you have interest in my topic, please contact with me. Thank you.
Hello and welcome to this presentation on my paper, A Writing Typology for Designers. I'm Madison Sabatelli. I'll be starting off with an introduction on writing for design. Writing empowers designers to narrow down their options with verbal means of description, making more pointed and specific design choices not to be overrun with familiar and repetitious imagery. Design typologies are used to further inform and make easy reference of common phenomena when designing. A writing typology is positioned as a way of breaking free from confines of the visual regime, often aligned with the design process. To develop this writing typology, documenting written communication aims to highlight writing as an accessible practice within design. This next section will discuss the methods of investigating writing used by design students. Utilizing an ethnographic approach, the study examined 3 design courses at a large public American university. 3 design studios were recruited for the study in order to show a range of instructor approaches, curricular activities, design disciplines, and student skill levels. Studios observed included Studio 1, a fundamental course for first-year students wishing to major in a field of design, and 2 advanced collaborative studios for those majoring in interior design, industrial design, and visual communications. This included Studio 2, which was centered around inclusive design, and Studio 3 on retail design. Methods of inquiry included surveys, classroom observations, informal and formal interviews, and accumulation of students' process work, notes, sketches, models, and other forms of documentation used to establish a final design. While gathering this data, I performed several rounds of qualitative coding to start making sense of the findings. This included descriptive coding, or essentially naming what was being observed and documented from an initial perspective, process coding, which allowed for more in-depth analysis of the writing by placing it into the context of the actions of students, and finally concept coding, which allowed me to see a broader amount of themes and overarching values of writing. To then present these findings, I'll discuss the writing types identified. First, building a design mindset utilizes writing to help students become familiar with fundamental knowledge for their studio as they are introduced to new information. In Studio 2, students began using this type to assimilate observational notes from a class trip to design an urban space. Students similarly text-filled sketchbooks house descriptions of landmarks, rhetorical questions, and considerations for human interaction, all drawn upon by introductory course material presented by the instructor the week before. Next is writing as making connections. This writing type served as a kind of hinge for students to begin building on provided language and material. With the grammar of a design mindset, students worked to translate what was presented in their own words. In Studio 1, the language of design was still a new concept that many students were learning to grasp. One student used writing to draw parallels between intangible concepts such as progression and change to embody physical design qualities such as fade or dissolve, employing the tools and language presented. Writing becomes more of a robust tool in forming design concepts with quick ideating. Unhindered by the burden of getting the still formed ideas right via drawing and empowered by the convenience and simplicity of words, students turn to writing as a way to quickly convey their ideas. One student's iPad screen portrays the physical qualities and perceived execution of design considerations. Text prevents them from adhering to a confined form or spending too much time working out a visual representation for each concept. Writing continued to make its appearance as captions to clarify the intention of drawings and describe what can be communicated visually. In Studio 3, student groups arranged words and images on large boards to begin compiling a visual and textual representation of their projects. Captions bordered images, qualifying the visuals with adjectives like soft and justified, as well as verbs like being connected and outcomes like guided discovery. While writing has since been used in ways to explicitly aid in the learning of major design concepts and the formation of new ideas, it also takes on a more background role in the form of planning. An example from Studio 3 highlights a group project's documentation of collective tasks, expectations, and key ideas, ensuring the internal thoughts were externally documented and communicated. Giving and receiving feedback have always been important components of design as well. While these activities may be primarily thought of as verbal, writing facilitates feedback while providing opportunities for students to both compose and interpret text to improve visual designs. As evidenced in this example of an online discussion board for Studio 2, textual conversations between students effectively crystallized feedback in a more permanent sense than verbalizations alone. Finally, students use writing to document and process their ongoing thoughts throughout their projects. While design often focuses on constant iteration and doing, reflection offers an opportunity for students to slow down, ask themselves questions, and revisit other writing types. Although students were required to record and document their processes in Studio 1, most seem to appreciate the reflection despite it being a tedious task. In this way, reflective writing mirrors the iterative aspects of the entire design process, which requires students to constantly ponder their choices. These writing types inform some of the overarching themes of the study, further implicating the importance of writing in the discipline of design. Each of the courses demonstrated strong connections between writing and the mentorship role of instructors, the social nature of design, and student reflection and self-awareness. Within the educational context of the studio, instructors employed writing pedagogies to connect academic conventions with disciplinary values. With this, instructors embedded writing in their teaching practices while modeling what it means to be a designer. Interactions between students and instructors can be similarly expanded to those between students and their peers. In each of the studios, the learning and acquisition of new terminology and concepts did not take place in silos. Writing facilitated online and in-person discussions, with students serving as scribes of studio dialogue. Finally, design students presented ways in which they used writing to not only reflect on their designs, but themselves as learners and emerging designers. As students move through the steps of the design process, they remain aware of writing even as design components become more dependent on images and sketches. So, what does this mean for design educators, students, professionals, and the community at large? For educators, we may think more about integrating writing as a characteristic of studio culture. Students need to practice writing through low-stakes assignments and work on applying this creatively, and professionals may be able to inform writing practices used within the field. Thank you.
Okay, so I'd like to thank all of our presenters for creating what are really informative and interesting videos there. I realize it's always a challenge trying to fit everything in such a small time scale, but you know, well done in that respect. Can I just ask Flavia, might need to type this in on the chat, but just to let us know whether or not your microphone's working. And Stefan as well, I don't think either of you really had a chance to test your microphones. So if they are, then you can let us know verbally. If they're not, then let us know through the chat.
Can you hear me?
Perfectly.
Okay, yeah, I found kind of a trick.
Yes, so that's great news. Just a reminder for everyone else, there is the chat function there for questions. If you can think about what you would like to ask our presenters, then I'm sure they would appreciate it. If you can type it into the chat, but put the presenter's name first, then we'll know how to make sure that everyone gets an opportunity to answer questions. However, what I'm going to do is get a start, and hopefully that will inspire people. I'll try and make sure everyone gets a question, so I'll rotate around a little bit there. It's a question to start with for Khadija. So the focus there was on testing, and I think it was interesting, you know, this idea that we perhaps don't teach students how to test within their product development. You'd identified a number of different definitions of what testing was. There was verification, validation, prototyping. But I guess ultimately what we're doing here is testing against a set of requirements, which are ideally defined at the start of the development process. So just in that respect, we know we have specific design processes that we can use to design types of products. But to what extent does the testing need to be specific as well? If we're actually testing against quite possibly a unique set of requirements.
Okay, if I understand your question correctly, so to start with, as you have said, there is a process for product development, and if we take a simpler process like idea generation and then demonstration, concept demonstration, or system development, and then verification and validation. Obviously, we can relate testing for the verification and validation, but our assumption is from the very beginning, there are a lot more testing which could be it's internal for experimentation, for understanding, so reduce the uncertainty. So what could be the value? If we do this, what's going to happen? So those sort of testing, which can happen physically, very low fidelity model building, or is a kind of physical model building. So those all are testing with it. Is it a set of requirements that satisfy the customer? That's a different question. Or who is the stakeholder? Is it the internal stakeholder for learning at the beginning, for kind of idea generation, or to a concept stage, talking to the user that who will be using? So at each stages, our understanding, there is a testing bit in a different form, different mode, different reason. But how that is integrated with the design, how we do design and we learn and we test and then we improve, and how this iteration happens in the process is not very clear in typical product development processes. And that's where we want to emphasize that how does a student know that they probably know by designing and doing so, but is there any kind of prescribed or described method in our books that a student can follow if they don't have that experience, and how they learn how to do, what to do, and when to do, and what they have learned, how that can be used in next phases. So I don't know if I've answered your question.
Yeah, I think that is a good answer. I mean, we obviously go through stages throughout a conventional product design process, and that the idea that we may use models, some fairly low resolution prototyping at an early stage is something that we see, but perhaps in the later stages, if you go into an embodiment design stage, one of the important things is how does it actually work? Where's the proof that it does work? Which is, testing is the means to do that. I think, perhaps in some programs, the prototyping is used or has more emphasis than what it should have. Whereas when you get into the embodiment design stage, you actually need, hard evidence that it actually does what it needs to do. Yeah. And I think, I suppose it does still depend on the type of product that is being made to understand what that testing may be. Okay, right. So I have more questions, but I'm just going to keep a track on who gets asked these questions, and we'll try and rotate around. I see there are some questions coming into the chat, which is great to see. But we need to make sure everyone gets an opportunity to answer questions. So I'm going to move on to Stefan.
And I have a question there, but you want to come back later? I can come back later.
Yes, if you don't mind, Khadija,
that's fine.
I'll try and make sure that everyone gets asked questions. And if anyone has a question for any of the presenters who haven't asked a question just yet, then please, by all means, put it into the chat. but we'll try and get around these questions quickly. So for Stefan, so we know additive manufacturing's becoming more of a means that students use in order to do prototyping, like what we've just talked about, and perhaps even further than that still. One of the things that I've observed is that we see students that perhaps have additive manufacturing technology at home. It seems to be more readily available. And I guess the question there is, to what extent should we be relying on students perhaps having their own practical experience of using it, and then supporting that as well through perhaps more formal learning techniques? So, it's this practical use at home of a technology that we see more and more frequently. How should we support it within education?
Yes, you can see that you're right. Also, our students, I can recognize that many of them already have their own 3D printer at home, and they use it for small projects. But I think if you have a closer look to the product development of more complex products, they should know more than only one method, like, for example, the fused deposition method, which is normally used for home printing. They should also know something about multi-material printing, for example, and they should also recognize that they have to design a part. They have to consider material properties, which could be differ for different parts in one product, for example. So it's also additive manufacturing is, if you have a closer look on it, it's more complex than just having an idea and have a 3D print from it. And that's why we intended to do this class, because it's also a class which we provide only not for the bachelor's, but for our master students. So we can expect that they have already.
It looks like Stefan stopped. Hopefully everyone can still hear me okay. Okay, right. So hopefully Stefan will come back and finish that question, but there is a slight overlap there with some of the questions that I had for Flavia. And I think it was an interesting idea that, in essence, we are seeing more and more novel materials that influence our process of designing. And I guess perhaps more recently we see materials that really change the way we think, so that we don't perhaps go through a conventional design process and then decide on the materials. A material comes along and we think, actually, what can we do with it now? And there is a slight overlap there with what Stefan was saying, not material-wise perhaps, but more manufacturing process related. So how do you see that working, Flavia? Is it both? I mean, do we get new materials and it just radically changes the way that we think about designing until a point where we become more familiar with it and it's more, okay, we can choose this material now? Or how does that influence our innovation? And how do we teach and keep up with that from the education point of view?
Okay, can you hear me?
Yes, we can.
Perfect. So thank you for the question. I think that actually is both ways. We can read this, let's say, introduction of innovative materials into the plethora of material alternatives we are continuously stimulated by. Actually, the introduction of such novel materials into the possible material alternatives, since usually they are behaving in a very different way from the classical material families we are used to work with, actually they trigger a lot of innovation. On the same time, it is difficult to manage with current manufacturing processes these new material classes, mostly because we of course, do not know enough until now, since the competitors of these new material classes are materials that we are used to adopt in our design since very long amount of years. So they are quite brand new. We need to study them in order to understand how they could be managed, how they could be processed into an industrial reality. And this is a little bit the clue of our proposed work, since if we are continuously stimulated by these new materials, but at the same time we cannot manage them properly, the risk is to deploy a material just because in a certain product and not exploiting its main and its functional features, let's say, in the most suitable way. So to understand how and study how materials can be managed is something that is compulsory in design education. And since the knowledge upon these new material classes is still poor because of the time they have been discovered, we are trying to push the students to build kind of a critical eye, not against, but on the respect of these new material classes, in order to not fall into the fancy adoption, let's say, of these new material classes, because they are very attractive and very interesting, but to understand how and how to properly deploy them into effective components or products by having a critical analysis of them. So, of course, the manufacturing processes and the materials and their selection are for sure interlinked, intertwined together. So that's why we ask also students to understand the level, the maturity level of these new materials, if they are industrialized or still in laboratory scale production, just because they are, the two arguments are, the two topics are very intertwined. And of course, it also follows that also the form, the final shape of the product is, however, affecting the overall design activity, but this is nothing brand new. So the most important thing that we want to focus on is to invite students to be aware of what they are looking at, to have kind of a method to read the information that they are achieving, that they are finding into the web or into material libraries and so on, in order to make an efficient deploy of certain new materials into their products. And in the same time, as researchers, we can monitor the trending of these new material classes in order also to define possible new material classes typologies, since they do not fit into the real existing ones, and probably it is worth to give some space, specific space, to these new materials. I hope that the answer was
yeah, a good answer. I think drawn back to Stefan with the additive manufacturing. I mean, obviously, what that has done is quite significantly affected the shape of what it is that we can create, because we perhaps couldn't create things like this in the past without additive. And I suspect, it may be that what we see is that it's something similar through the use of these novel materials that allows us to change the shape of the products themselves using these materials. There's a couple of questions here. There's one from Lucien, which is aimed at everyone. It's, I guess, a valid question that all people in education wonder what should be included in curriculum and what shouldn't be. And the point is that we have these new trends that have been presented this afternoon. And the question is related to the curriculum already being very full. And what should we pay less attention to? So we have these new trends. What is potentially obsolete? This is a question to everyone. So if anyone is comfortable answering this question, then please, by all means, do so. Perhaps it may be something that you are more familiar with from an educational point of view. So any answers to this?
I can start with, if it's okay.
Sure, absolutely.
Yeah, it's not to kind of absolute anything, but it's just the way we think, because there are new technologies coming, new materials and everything. So we have uncertainties, lots of risk associated with our design. So for me, again, because the topic I'm very interested in, we probably need to teach students to start testing earlier, not a testing in terms of physical artifact has to be in a test bed, but is the test of the idea will work or not. There are many forms of testing, and I would say computer-aided engineering is one form of testing which students does anyway, but it's just my point is that companies and education, we can see the way the designing, understanding, testing, and the iteration is existing, but we don't see the reflection in the books. Of course, the books we have analyzed are old, and it's of course it's coming in the future, but it's probably more reflection and emphasis on the types of work, the analysis they need to do from the start, and how they pinpoint their idea from the very beginning, validity of their idea, verification of their idea from the very start of the process, design process. That's what I would say needs to be emphasized. But I would not be brave enough to say what needs to be discarded.
Yes,
not really.
It's a tricky question to answer on that one, I would say. I mean, ultimately, I guess it comes down to what the foundations are that you absolutely need to keep a hold of. But, you know, is there manufacturing processes that aren't as relevant these days? Is there choice of materials that aren't as relevant these days, or creativity methods that aren't as relevant, or means of communicating that aren't as relevant, that we should consider either revising that or dropping it altogether? I think is ultimately where the question has come from. Not an easy one to answer.
Maybe I can try to answer a bit. I agree with my colleague, since we cannot, even if we are plenty of information, plenty of innovative trends and so on, we cannot discard something or pay less attention to something, in my opinion, since new is is not sure is better. Let's say testing as well as promoting a critical analysis of the new trends, of the novelties, I suppose is something very healthy in terms of both educational and research, since without having a let's say an attention, an aware study of the novelty, it would be difficult and also probably not only riskful, but also, let's say, dangerous to underestimate certain risks or certain, let's say, specific descriptors or specific properties of what we are analyzing as a new trend. So novelty does not mean necessarily that is something better and can take place of well-known, for example, technologies or materials, since well-known technologies, materials, and so on, sometimes can be also better than the novelties itself. So we should foster the students and also the research to maintain a certain balance, to maintain a critical aspect, to test the novelties before embracing them, of course, without guided from the enthusiasm.
Yeah. Okay, good. There's two more questions here, which I think we'll work through, but I think I would add to that and say, I think there is a need to understand what industry demands as well, and how we make sure that we keep up with an understanding and the requirements of the industry that we're actually ultimately delivering graduates for. So this next question is from Ross for Zhengya. I'm sure you've had an opportunity to read it, so I don't think you need me to read it out, but I'm happy to if you need. Zhengya?
Yes, I'm here. Yes. Can you hear me?
Yes, sure. Would you care to answer it?
Yes. Actually, we asked a question in the questionnaire, like which country you're from and which university you are studying. So we cannot sure all the students or all the participants from the different country or city, but at least in our questionnaire is more than 20 university included in our study. Also, the participants are from like also more than 20 countries. And because the exclusion research before, so we exclude some like the participants, like they haven't joined a creativity related course, or they from the developing country or undeveloped country. So finally, the results also include more than 10 countries and maybe around 15 universities. Yes, I know it's a kind of limitation in our study because we didn't get a huge sample size, but it's just to investigate a little bit and to know like the gap between China and developed country, and maybe it will help a little bit for the Chinese higher education get something or how where we can like improve or develop our higher education. Yes.
Yeah. Obviously, I think it's useful to get as wide a picture as possible, both across China and across the other countries that you're interested in exploring the differences in. And I think once you actually get answers to some of these questions that highlight that there may be differences, that then provides you an opportunity to explore more about where those differences are and why they are there. The next question is for Madison. Hopefully you've had a chance to read it, and it's a relatively short question, but I think there's another part to it that I would like to add to that question. So Madison, over to you.
Yeah, I definitely thought of the writing that I observed in these 3 design studios as specifically just pertaining to text. There were plenty of instances in those images where the text was accompanied by images, but I was kind of thinking about the cognitive processes that you have to take to decide whether you're going to draw or write something. And so there's a little bit of a difference in, okay, I don't know what it's going to look like, but I know what I want it to do, or I know if I want it to be kind of like these other ideas that I'm not quite sure how to visually arrange that yet, but I can describe it, or I can write about who I want it to serve or what actions whatever this design needs to fulfill. Okay.
So I think it's a really interesting area that is probably under considered really in those early stages of design. And I often say to my students, look, if you describe, if you can write about it, then you'll get a better understanding of it rather than drawing. And I think that's certainly come out with what you've presented there. But I was just wondering as well as what your thoughts are, if there's any differences in skills needed to practice and apply these different writing types. And I think the motivation for that question came about as a result that we often see some students who are able to graphically illustrate something really well, and there's different levels of skill there. So would you anticipate that there's different levels of skill from these different types of writing that you would expect to see as well?
For sure, yeah. I think I in this study and in a couple of other positions that I've held, I've run into a lot of students who say that they think that they're bad writers and they can't produce good writing. But I've run into a lot of designers as well, or design students that started out or maybe still believe that they're not good at drawing or sketching. But we have the activities and rigid courses to produce those types, or at least help with those types of skills. So why not try to cultivate this better sense of being a good writer to get those same kinds of design outcomes?
Okay. I think we've probably got time for one more question. I realize that the session's due to close soon, but it's a question from Yulan Zhengya. Hopefully you've had again a chance to read the question there. So I know that some Chinese universities place a high value on design, but some are not. And the question is, do you think this could be impacting?
Yes, I'm here. And I know it's a difference between the different city or different region in China, like for some big city like Shanghai or Beijing, especially like Tongji University is like put a design and a creativity in a higher value. But in some middle-sized city or some middle-sized university, maybe they are a little bit overlooked design or creativity. They have different situation because China is a big country. I'm not saying like Chinese higher education don't care about design creativity. I just point out there are something maybe we can like improve or develop, make it better. And do I think it could be impact something? I think so. After when we like graduate, because I'm PhD student, and when I go back and like contribute for the higher education or something, we will change it. We will make it more better. Yes, it just needs time. Yes, thank you.
Okay. And we may have time for one very quick question there, Madison. Hopefully you've seen this one come in. It might be a simple yes or no answer, but just keep an eye on the time and we'll try and fit the answer in.
Short answer is yes. That last writing type, focusing on reflection, that's I think a really big part of all of this, and that plenty of students are reflecting on their design choices at multiple stages throughout the design process, but maybe don't keep track of them or forget to document it, maybe make the same mistake next time. So having maybe a more formal sense of reflection would be helpful with writing.
Okay, and a critical reflection, I suspect, there as well.
Mm-hmm. Mm-hmm.
Okay, so I think keeping an eye on time, that will have to bring us to a close. What is interesting with a set of presentations like this is I think the discussion and the conversation and the questions could carry on well into the evening or morning, depending on where you are. But I would like to thank you all. I think that the presentations have been really interesting and some really insightful answers to these questions that we've had posed. So thank you. I hope to see you soon, hopefully face-to-face next time round. Take care and enjoy the rest of the conference. Bye.
Bye-bye.